Correct interpretation of the parameters in the script is sometimes problematic. That's why in the coming lessons we will discuss a few possible ways of accepting parameters in your script. In our scenario, we want to develop a script that will generate a kind of report and will accept following parameters. -r, informing that indeed the report should be generated. -d, causing that the previous version of the report should be removed if existed. -f, pointing to the file where the report should be saved. Additionally, we want to be able to start the script with the option -h that will display a short manual of how to use our script. Should the user start the script with some incorrect options, we will display error message and advise to display help message. So, how to organize the script? At the beginning, I decide to put variable definitions. They will somehow reflect the parameters that can be sent to the script and will have default values. Those variables may have incorrect values. After accepting all the parameters, we will need to do a check if all the variables have logical meaning. Here, the variable makeReport has value of n. Don't produce the new report. The variable deleteReport also has value n. Don't remove previous report. The file name is empty, so generally, with the current values of the variables, we are going to do nothing. Don't create and don't remove, and moreover, we are going to use an unknown file, empty. But no worries, during the process of acquisition of parameters, we will try to get a set of values that make sense. It's time to process the parameters. That can be done like previously shown with a loop iterating so long as all the parameters are processed. The $hash reflects to the number of arguments and this number should be greater than 0. Every time after processing an argument, I will move them using the shift command. So every time the $hash will be decreased. And now it's time for a bit magic. Instruction case that we are meeting on this course for the first time. Whenever your program has to make a choice, decide about something, it could use the command if. However, when the number of possible choices is high, you may create a huge if. If the value is equal to something, then do this. Else, if the value is equal to something, do that. Else, if the value is equal to something, do this. And finally, if no match was found, do something else. We would like to avoid so big if, elif, else statement. That's why the instruction case was invented. At the beginning, we need to tell which instruction or variable should be evaluated. In our case, that's the current first argument, so $1. Now, below in separate sections, we will define conditions and what should happen if the condition is met. Look, here I define that if the current $1 option is equal to -r or --report, then following actions should be taken. Display diagnostic message, change the value of the variable makeReport to yes, and shift the parameters. Very important syntax that needs to be followed is that when the sections of instructions are finished, we need to write 2 semicolons. The second option that we want to accept is -d or --delete. What would be done here? We will display diagnostic message, change the value of the variable deleteReport, shift the arguments and finish this section with 2 semicolons. The next parameter could be -h or --help. If used, our script will behave a bit differently. We will display a short manual and after it finish the script, so this option seems to be more important than the others. The 2 semicolons are required by syntax and must be present. In the displayed message, the variable $0 will be replaced with the script name. Next, we have a symbolic description of acceptable parameters, like in many help articles that you most probably have seen multiple times. And now, the most complicated parameter -f or --file. We will start with displaying diagnostic message. The report will be sent to a file. But wait a moment, how to get the file name? because each time when the arguments are processed, we shift them, so now when the option F was used, the file name should be the next argument, so $2. So now we can write file equals $2. Note also that this time we have processed two arguments at once, so we need to move the arguments twice with the two shift commands. It's still possible that a bad user could run my script passing other arguments that the script will not accept. We will service such case in the last section. If anything else was sent, we will teach the user how to use -h parameter. As that's a kind of an error, we can exit the script with non-zero exit code. Note that in this case, the command shift is not needed. The script will end, so we don't care about shifting arguments anymore. Now we have read all the parameters, but we don't know if they are correct, so we should somehow check them, without discussing the syntax. If the file is empty, then we are going to display message about error, and we will exit the script with error code. If needed, we could put here more if statements checking the arguments, and this section could be big and complicated. Here I will check only this one condition. Now it's time to write the instruction that will finally perform the script activities. I will also try to keep things simple. If the existing report should be removed and the file defined with the -f option exists, then we display a message and try to remove the file. If something goes wrong, we will exit the script with error message. If the user wanted to create a new version of the report, then I will display a message stating that the report is going to be generated, and I will somehow produce the report, saving it in the file. Should this for any reason fail, I will exit the script with error message. Well, if the script reached that point, then believe me, we have success. Good. Now we can check the behavior of the script. When running the script without parameters, I have message teaching me that the file parameter must be defined. Second trial. I will use the -f option, but I will skip the file name. And again, error. The file was not defined. Good. Let's run the script with the option F and a correct file name. Now the parameter F was correctly understood, but the report will be not created, not deleted, so generally apart of the diagnostic message, nothing more happened. Now I can append option -d and -r. All of them should be understood by the script. The old version should be removed if existed, and the new one should be created. So now the file tmp report.txt should contain one output of the df command. Nice, we got it. But I can run my script skipping option D. As a consequence, a new version of the report should be appended to the existing report. Let's check it. Indeed, the report file is now bigger. Of course, I can run my script with parameter D but without R. As a result, the old version of the report will be removed, but the new one will not be created. So when I try to display the file with report, I have error, no such file. Very good. And what will happen if starting the script with unknown option, for example X? The script discovers error and advises me to check for the help. Maybe not a bad idea. When starting the script with option -h, I can see a short syntax summary for the script. When interpreting the options, we allowed to send long option names, so now we can use them as well. Report --delete --file. Diagnostic messages displayed now show me still the short version of the parameters, but no problem, the long options worked correctly. And so we could play with the options forever. To recap, let's review the most important parts of the script. At the beginning, the variable definition. Sometimes the values visible here will not make sense at all, like the empty file name here. The next is the while statement. The while should process all the parameters, Because internally in the loop, we are moving the variables with the shift, the $hash will decrease, so the good loop statement is comparing the value of $hash with 0. When using shift, the $1 always points to the in a moment analyzed argument. The instruction case, used here internally in the loop, simplifies analysis of complex conditions. The case can be used generally whenever you want to make a more complicated decision in your script. Depending on the value in $1, we start an adequate section of commands. Here, mostly we decided to set a new value for the variable and execute shift. Sometimes, however, when something more should be done with a given option, like here with the F option, something more interesting can happen. Here, the next parameter value was taken, and also the shift was executed twice. That's not a bad idea to handle also incorrect arguments. Asterisk. In the next step, the parameters, or more precisely, the variables containing parameter values, should be tested for correctness, what allows to develop better quality scripts. The final step is the true execution of the commands. So, as you see here, the part of the script that interprets the arguments may be a bit complicated and long. That is why we have a function called getObts that we will discuss in the next lesson.